Ladies and gentlemen, my name is Benedikt Badánik, and together with my colleagues from the Faculty of Operation and Economics of Transport and Communications of the University of Žilina, Slovakia, I have prepared a presentation on the life cycle assessment of conventional vehicles. In this presentation, we will get acquainted with the basic knowledge of combustion engines, we will talk about European emission standards for the road vehicles, and finally, we will clarify the basic methods of fuel consumption measuring. Let's start with knowledge about combustion engines. According to the European Automobile Manufacturers Association, more than half of all European passenger cars run on petrol. Passenger cars with small petrol engines are more common than passenger cars with medium-sized and large engines in majority of member states. An internal combustion engine is an engine that works on the principle of burning fuel, so an internal combustion engine is called the heat engine. When fuel is burned, chemical energy is converted into mechanical work. The chemical reaction occurs during the combustion phase of the engine. In this phase, thermal energy is generated and converted into mechanical work by the use of suitable gas medium. Standard petrol engine operates in 4 strokes. First stroke is intake. In this stroke, the piston moves downwards, increasing the space above the piston and opening the suction valves. Second stroke is compression. In this stroke, the piston moves upwards and compresses the mixture, which is heated, and the result is increased pressure. Third stroke is expansion or power stroke. In this stroke, a spark plug ignites the air-fuel mixture, and the resulting combustion quickly expands the gases, forcing the piston back down the cylinder. Fourth stroke is exhaust. In this stroke, exhaust valves open to help get the exhaust gases out of the cylinder. The main advantages of petrol engines are simpler and less expensive construction. Petrol engines are more powerful, and petrol engines are more suitable for shorter routes because the time to obtain the operating temperature is much shorter. Standard diesel engine operates in 4 strokes. First stroke is intake. In this stroke, outside air enters the cylinder through an open valve. Second stroke is compression. In this stroke, the piston compresses the air in the chamber 16 to 25 times and reaches the temperature of 700 to 900 degrees centigrade. Third phase is combustion. In this phase, fuel is injected into the chamber and ignited. Fourth stroke is exhaust. In this stroke, the piston moves upwards, the burned gases are discharged into the exhaust. The main advantages of diesel engines are: the service life of the diesel engine is twice that of the petrol engine. Diesel engines burn 30% less fuel on average compared to petrol engines, and diesel engines provide higher torque at lower speeds. The European Union issued directives that apply to all European member states. Later, the directives were changed to EU regulations. EU regulations are divided into 2 basic groups. First group is represented by emission regulations for passenger cars and light commercial vehicles. They started as Euro 1, continued as Euro 2, Euro 3, Euro 4, Euro 5, and nowadays Euro 6 is valid. Second group is represented by emission regulations for heavy trucks and buses from Euro 1 to Euro 6, that is valid nowadays. Regulated emissions include particulate matter, nitrogen oxides, hydrocarbons, and carbon monoxide. Emission limits were first regulated by Directive 70 of 2004, later replaced by EC Regulation 715 of 2007. Regulation 631 from 2019 of the European Parliament and of the Council applies to new passenger cars and new commercial vehicles. It replaces Regulation 443 from 2009 and Regulation 510 from 2011. Regulation 631 from 2019 seeks to comply with the Paris Agreement, for the period 2021-2030, ensuring greener road transport, reducing high emissions and thus reducing greenhouse gas emissions. The Paris Agreement sets CO2 emission limits for new passenger cars and new light commercial vehicles. The Paris Agreement aims to reduce greenhouse gas emissions by 30% by 2030. In this table, you can see an example of Euro 6 emission limits for vehicle categories M, N1 and N2 with both petrol and diesel engines. The Euro 5 was the first standard to introduce particulate filters referred to as DPF or FAP for all new diesel vehicles. DPF or FAP is the filter mounted in the exhaust system and supplemented by the catalytic converter, which aims to capture up to 99% of all particles. To meet the new Euro 6 emission standards, some manufacturers have introduced selective catalytic reduction, in which AdBlue is injected into the exhaust unit of the diesel engine. The final part of this presentation is devoted to methods of measuring fuel consumption. The method of measuring fuel consumption should be accurate and reliable. To ensure the required measurement results, several methods have been created. Depending on the place of execution, the methods can be external and internal. Depending on the modes of operation of the vehicle, the methods can be based on predefined operating regimes of the vehicle and normal operating regimes of the vehicle. Depending on the method of determining the amount of fuel consumed, the methods can be volumetric and weight. The driving tests are performed on the road or test track. This is the test in which the operating conditions are simulated. The resistances acting on the vehicle are of the real nature. Therefore, it's necessary to choose the right measurement procedure so it is as realistic as possible. Driving tests can be substituted by the dynamometer tests. They are performed when the suitable test track isn't available or when the large number of measurements are made. These tests are frequently used by today's car manufacturers. In this measurement, the vehicle is placed on resistance cylinders, which are set to simulate pre-calculated theoretical driving resistances acting on vehicle. Individual measurements are carried out according to predefined operational conditions. The measured values correspond to the fuel consumption, and they help to determine the influence of various factors on the fuel consumption. The individual measurements can be compared with each other. One of the most reliable methods of measurement is the measurement of fuel consumption at different speeds. This method requires that the slope of the track and the weight of the vehicle and load must be defined well before the measurement. Driving cycles determine the dependence of vehicle speed on time. They are created by different countries and organizations to suit urban or extra-urban traffic. Driving cycles can be divided from several points of view. From legislation point of view, driving cycles can be divided into the legislative driving cycles and research and development driving cycles. When it comes to the dependence of speed on time, the driving cycles are divided into actual driving cycles and polygonal driving cycles. The most frequently used driving cycles in Europe are ECE15, EUDC, EUDCL, NEDC and WLTP. Driving urban cycle ECE15 consists of 4 identical parts. Each part is 1.013 km long and the vehicle passes this part in 195 seconds. The total distance traveled during the cycle is 4.052 km in 780 seconds. The vehicle accelerates from rest to the steady speed of 15, 32 and 50 km an hour with an average speed of 19 km an hour. EUDC cycle is an extra-urban driving cycle lasting 400 seconds, during which the vehicle travels 6.955 km, reaching an average speed of 62.6 km an hour. The maximum speed during this cycle is 120 km an hour. During this cycle, the vehicle accelerates to 70 km an hour, then decelerates to 50 km an hour, and accelerates again to 70, 100 and 120 km an hour. EU DCL cycle is similar to extra-urban driving cycle, except of the fact that it applies to motor vehicles with lower engine power. The maximum speed reached in this driving cycle is 90 km an hour, and the average speed of the vehicle is 59.5 km an hour. NEDC, or New European Driving Cycle, consists of 4 parts of the ECE15 urban cycle and 1 extra-urban part of the extra-urban driving cycle. The total duration of this cycle is 1180 seconds. During this period, the vehicle covers 11.007 kilometers. The average vehicle speed during the driving cycle is 33.6 kilometers an hour. At the beginning of the cycle, temperature of the engine is between 20 and 30 degrees centigrade, and the vehicle must travel at least 3 kilometers but no more than 15 kilometers. Weight of the driver is 75 kilograms and weight of the load is 100 kilograms. World Harmonized Light-Duty Vehicles Test Procedure, or WLTP, is very realistic because it corresponds to actual operating conditions of vehicles in road traffic. This cycle is divided into 3 classes, which express the power-to-weight ratio of the vehicle. The cycle for Class 1 consists of low and medium speeds. The total duration is 1022 seconds. The total distance covered is 8.091 kilometers with an average speed of 28.5 kilometers an hour. The cycle for Class 2 includes low, medium and relatively high vehicle speeds. The total duration is 1477 seconds, the distance is 14.66 kilometers and the average speed is 35.7 kilometers an hour. This driving cycle for Class 3 consists of 4 parts of different types of traffic: urban traffic, extra-urban traffic, traffic traveling at relatively high speeds, and traffic traveling on highways. The distance traveled during this cycle is 23.262 kilometers, the duration is 1800 seconds and the average speed is 46.5 kilometers an hour. Now let me talk about 2 methods of determining of fuel consumption: the mass method and the gravimetric method. Mass method uses the fact that the amount of energy in the fuel depends on its weight. Therefore, the consumed weight of fuel directly determines the intensity of the energy. The principle is that the fuel in the tank is weighted before and after the measurement, and the difference in weight represents the weight of consumed fuel. The weight can also be monitored at some specified intervals or continuously during the measurement. This method is usually used to determine engine consumption or total vehicle consumption in a steady state. It eliminates the difference in specific weight of fuel in the incoming and outflow branches caused by fuel heating. Therefore, it's mainly used for scientific and research purposes, and it is adapted to laboratory conditions. The second one is volumetric method. This method, as the name implies, is based on the measurement of the volume of fuel consumed. The amount of fuel is expressed in units of volume. The consumption of road motor vehicles is most often expressed in liters per 100 kilometers or liters per engine hour. This method is more flexible due to the measurement procedure and the instruments used. Therefore, it's used for driving tests outside laboratories. Due to the changing fuel density caused by changes of the ambient temperature and atmospheric pressure, it's necessary to convert the volume of fuel consumed to the volume adjusted to standardized values.